One area that is of particular concern to scientists in the modern era is that of reproducibility. So, in theory, a scientific result should be discoverable by anyone. And so, if I was to do an experiment, you should be able to do the same experiment and discover the same result, which we call repeatability. Unfortunately, although this is nice in theory, science is not proven to be as repeatable as we would like. So in the past 10, 15 years, there's been a growing awareness in the scientific community that a lot of published research might not actually be repeatable by other people. So this graphic was taken from a survey in 2016 asking professional scientists about their experiences with the reproducibility. And this first slide shows the results of asking them, have you established procedures for reproducibility in your own scientific work? And the answer was not as many as we might ideally find, right? A full third said no, and only 7% said more than 7 years ago, right? So the majority have never done it or have only started doing it recently. Even more concerning was when they were asked whether they had ever failed to reproduce an experiment or had ever tried to share the results of reproducing an experiment with other scientists by publishing a formal scientific paper about it. And so we can see on the left here the results of being asked whether they had failed to reproduce an experiment. The darker red bars show whether it was somebody else's, and the lighter pink bars show their own experiments. And across all the fields of science, we can see that a pretty high number of people have failed to reproduce an experiment, especially other people's experiments, but often even their own. Then in this right-hand figure, we get the results of when those scientists were asked whether they'd ever attempted to publish a reproduction of an experiment. And, hopefully we would get, ideally, we would get published accounts of the failure to reproduce someone else's experiment, right? Because if one scientist says, oh, this is the results of my experiment, and then somebody else finds that actually when they do the experiment, they don't get the same result, that would be useful information to know. But actually, we see here the results for unsuccessful reproduction, right? So when someone was unable to reproduce somebody else's experiment, only 13% of them were published, and 10% of them were attempted to be published, but weren't able to do so. In other words, the publishers of scientific papers weren't interested in actually publishing that research. And there's a variety of different reasons why science wasn't or hasn't been as reproducible as we would like. A lot of these boil down to the fact that there's a lot of competition and time pressures on modern scientists. So there's a lot of rewards for doing new, exciting science, which incentivizes people to try and get to results as quickly as possible and sometimes maybe cut corners. There's also a lack of training in actually making sure you do science in a reproducible way, and not a lot of reward for scientists for actually doing reproductions. So here we're going to focus on making sure that the work we do is reproducible, and there's actually good ways to do this when we're doing science on computers. So one thing we can make sure we do is to share our data. If we're analyzing data, and we report the results of that, then we want to share the data so that other people can also analyze that same data and verify that they can also get those same results. We want to document our work, so we want to track what we're doing so that we or other people can look back at what we did and understand what we did and why we did it. And we also want to make sure that we share the code that we used to do the analysis. That means that other people can, in theory, just download our code and rerun it, and they can also see the choices that we made in our analysis.